everyone, welcome back to Sir Ran's math tutorial. We're learning math is made easy. We have a new lesson today guys, and it's all about solving quadratic inequalities since we're done with quadratic equations. So what is quadratic inequality? It is an equality in one variable with one unknown, usually in x, of degree 2. Then the symbols less than or equal to, greater than, and greater than or equal to are used to denote a quadratic inequality. So because we have four symbols, we also have four standard forms of quadratic inequalities, and we have here ax squared plus bx plus c is less than 0, ax squared plus bx plus c is less than or equal to 0, ax squared plus bx plus c is greater than 0. You also have ax squared plus bx plus c is greater than or equal to 0, where a, b, and c are real numbers and a is not equal to 0. We also have here very important terms to consider: critical numbers. Critical numbers are the roots of the corresponding quadratic equation of the quadratic inequality. If we solve quadratic equation, we're dealing with quadratic equation, then we call it roots. If we are dealing with quadratic inequality, we call it critical numbers. And actually, these numbers are not solutions, but locators. You will find out later on. Next is test intervals. What is the test intervals? Test intervals, or intervals into which the critical numbers divide the real number line into sections, and you will see how to write that intervals later on. And third, the test numbers, others call it test points. Any number taken from the test interval and are substituted to the quadratic inequality to determine if the interval is a part of the solution or not. Ayan, because we'll be choosing the interval as to the solution, so you will find out later. Ayan, so that you will understand everything that we have, let's have examples. Example number 1, x squared plus x minus 6 is less than 0. It's a simple example of quadratic inequality. Less than, and take note, it's just less than. And you know, in your previous note, when the sign is less than or greater than, it's an open interval. Okay. So tingnan natin how we can write it. So we will solve it this way. Alright, I hope you can follow. Let me check first my pen. So you have here x squared, copy the given. X squared plus x minus 6 is less than 0. So what will you do is you just have to treat it like a quadratic equation. So you solve for the roots, because the roots refers to will be our critical numbers. Okay, so if you are going to solve this one, of course you can use factoring as the easiest way, because it's a case 1 trinomial. Negative 6, you have factors of 6, negative 3, oh, it's a positive 3, and a negative 2 to make it negative 6, but when added, positive 1. Ayan, you have factors already, so you can now solve for the roots, because the roots will be our critical numbers. So equate h factor to 0. Okay, you have x minus 2 equals 0. Therefore, you have here x is equal to negative 3, which is your first critical number, and x is equal to 2, which is your second critical number. What's the use of these critical numbers? And that's the question now. If you got already your critical numbers, well, very good, because that will help you now find where the solutions are through the number line. So this one will serve as our locator. So where is negative 3 in the number line? Here. Actually, you are going to use that as reference where you are going to divide the number line into sections. So it passes through the number negative 3. Okay, so negative 3 therefore as our critical number is a locator, and we have positive 2 here. So positive 2 is here along that one. So you can see the number line is divided into 3 sections or regions, in which next you can do is write the intervals in that section. Okay, the intervals, I mean the values that are found in that section. This is open. When you are going to represent it with a symbol, that's this is how it looks like. Okay, it's an open. Here it's open and open, so it would be like that. And here, okay, it's open here because the sign is less than. So since it's open, we are going to use parentheses. Okay, So here, since here is negative infinity, so you write your interval this way. You start with negative infinity and then write 3, negative 3, open. So that's your interval in that section. Here, since it's open, start negative 3, ends with 2. Oh, not ends, actually, no. Technically, so it's a 2. Alright, open. It's a parenthesis. And here, it's an open 2 to the positive infinity. Ayan. So these are the intervals of the 3 sections. Now, in each interval, you need to test which of these intervals is true to the equation, to the inequality, I mean. So you will need the test numbers. Test numbers are actually test points, the same. You're just going to select numbers from this section here to the infinite, right? Negative infinite. So you can have negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. So for me, I'm going to use negative 4. And you can even use negative 10 and then negative 100 if you wish to. Here in this section, I'm going to use 0 because we have 3 and negative 2, negative 1, 0, 1. Okay? Here I can have 3 or 4 also because you have 3, 4, 5, 6, 7, 8, 9, 10, so on. Okay? These are called test numbers. Okay? That is called test numbers. So I'm going to have it first like that, so you will be guided. These are test numbers, the 3 of this one, and these numbers here, and this one are our test intervals. Okay, we call it test intervals. Okay, we have test intervals and test numbers. As you can see in our previous terms here, test intervals, the test numbers, and so we have already the critical numbers complete. We got the 3 important terms, and so we are now going to test these numbers using the factored form, but you can also use the original inequality, but to make it easier, I'm going to use the factored form to test these numbers, whether it's a solution or not. Okay, so I'm going to have, the section is a solution or not, so I'm going to have x plus 3 times the quantity x minus 2 is less than 0. So let me divide first. Okay, I'm going to divide the board into 3. So I'm going to substitute negative 4. So negative 4 plus 3 times negative 4 minus 2 is less than to 0. So negative 4 and 3 is negative 1, and then negative 6, negative 4 and negative 6, less than 0. Multiply negative 1 and negative 6, that's positive 6. Okay, and then the question is positive 6 less than 0. Oh no, it's not, so it's greater than 0, so therefore it's false. That means, guys, that the numbers here do not satisfy the inequality, therefore it's not a part of the solution. Okay, now let's test section 2 with the test point 0. Okay, so using the factored form, x plus 3, x minus 2 less than 0. Okay, I'm going to have a separator. I'm going to substitute 0. So 0 plus 3 times the 0 minus 2 less than this 0. Okay, this is 0 plus this is 3. And then 0 minus 2 is negative 2. Is it less than 0? Okay, 3 times negative 2 is negative 6. And that is less than 0. True or false? True, very good, it's true. Because negative 6 is always less than 0. Okay, we're now going to proceed to test positive 4 here in the third section. So using the factored form, x plus 3, x minus 2 is less than 0. This is 4 plus 3 since x is 4. And then 4 minus 2 less than 0. Oh, it's a 7 times 2 less than 0. Oh, it's a 14 less than 0. Is it true or false? Oh, false. Very good, it's a false. Therefore, you now check into the sections. Oh, with intervals. Where are the intervals that are true to the inequality. It's only the second section with interval open, interval -3 and 2. Okay, so that's your solution for that. So you can write your answer now. So the interval -3 and 2, that's an open interval. Okay, that's your solution for that. So you can just, have it as final answer. All right, since the other two intervals are not answers, are not true to that, so that's how simple. Let's have one example, more example. Okay, x squared minus 2x minus 15 is greater than or equal to 0. Let's try this out. We'll do the same. So x squared minus 2x minus 15 greater than or equal to 0. This time it's a greater than or equal to 0. You will notice the difference from the first given. So of course, case 1, you can factor that greater than or equal to 0. So you can factor 15 equal to, okay, you can have x minus 5 and x plus 3, right? -5 times 3 is -15, and -5 plus 3 is -2. Okay, since you have already the factors, you can now get your critical numbers. So x minus 5 is equal to 0, x plus 3 is equal to 0. So therefore you have x is equal to 5, that's your first critical number, and here you have x is equal to -3, so your second critical number. Because we are dealing with inequality, we call it critical number. Since these are critical numbers, this will serve as our locator here in the number line, the intervals. No, it actually divides the sections into intervals. Alright, so where is positive 5? Positive 5 is here, so located at the positive end of the positive side of the number line, and the -3 is here, so it passes through there. Ayan. So we have the first section, second section, and third section. Now, what will we do if we are going to show it? Because that's a greater than or equal to, that means if I'm going to do an arrow or line here, that's close, shaded. Alright, ayan. And here, a segment with endpoints shaded. Alright, and here, going to the right, endpoint here is shaded. Compared to kanina, open, 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 open. I hope you got the difference. And that when there is bar, okay, under the greater than or equal to, greater than or less than symbols, that's what you do. Okay, and then you will notice what's the difference upon writing the intervals. We can now write the intervals. Since it's close, it will be like this, no? Open, going to the left is infinite, so open, we don't know where it ends, so you write the interval is negative infinity, and then here close, -3 closed, it's not a parenthesis, and here you can write close -3 and 5 closed. So it's a close interval. Here you can have close 5 and then positive infinity, open. Okay, open because we don't know where it ends. Ayan. So now you have the test intervals, you have the sections already. After getting the critical values, you are now ready to select test numbers or test points. Select one from it. You can include -3 because it's a close. Alright, you can use -3 as test point, but I'll just make use of -4. Okay, here you can include -3 and 5 also. Yeah, the numbers here. Yeah, but I have here, I wanna use 1. I can use here 6. Okay, it's up to you. What number are you going to use? So okay, you're now going to test it using the factored form. So I'm going to test it. X minus 5. Again, you can use testing at using the, you can do testing using the original inequality. Okay, quadratic inequality given. So I'm going to use the factored form so that it will be easier. Okay, ayan. I'm going to substitute -4. So So negative 4 minus 5, negative 4 plus 3 greater than or equal to 0. Okay, wait, I'm going to draw a separator. Ayan. So negative 9, putting together negative 4 and 5, negative 5, and this is negative 1. Okay, greater than or equal to 0. So negative 9 and negative 1 is positive 9. Oh, is 9 greater or equal to 0? Yes. Very good. So you're going to say true. Yeah, it's true to the section, meaning this interval is already part of the answer, our solution here. Okay, so here we will test 1. So we will test 1. So going back, x minus 5 times x plus 3 plus greater than or equal to 0. Okay, I'm going to separate na separator. Ayan. So substituting 1, so it will become 1 minus 5 times 1 plus 3 greater than equal to 0. This is negative 4 times 4. Okay, greater than or equal to 0. So therefore it's negative 16 greater than or equal to 0. Is negative 16 greater than 0? Oh, it's not. It's a false. Okay, that means this region here, these numbers here cannot satisfy the inequality here given. So it's not a solution. Okay, and then let's try testing 6. So x plus, I'm sorry, that's a minus 5. Okay, minus 5 times the quantity x plus 3 greater than equal to 0. Okay, substitute 6, so we have 6 minus 5, and then 6 plus 3 greater or equal to 0. Okay, or 6 minus 5 is a 1, 6 plus 3 is a 9, greater or equal to 0. So 1 times 9 is a 9, greater or equal to 0? Yes, therefore it's a true. Very good. There you go. You have seen two sections with the test intervals correct. So therefore you can write your final answer. Your final answer is open interval, negative infinity close to negative 3. Of course, dalawa man, so you will have union. Okay, union to close interval 5 to positive infinity, open. So this is your answer. Okay, that's your final answer. Right, I hope that is clear. And let's have the last one. I think this will be the last one. Oh, it's a case 2. Okay, it's a case 2. Anyway, you can use a shortcut, just like the shortcut that I introduced in one of the videos that I have here. You can use it, but since the numbers are small, you can just mentally do it. Right? The factors of 12. So I can have 2x minus 3 and an x minus 4. Okay, that's right. Negative 3, negative 4, 12, and this is negative 3x, so negative 8x. Oh, negative 11 is correct. Right, so you have now your factors. You can now find your critical numbers. So your critical numbers equate muna, just like finding the roots of this one. Alright, then you have x minus 4 equals 0. Of course, this is 2x equals positive 3 divided by 2, both of the sides. You have x equals 3 halves. So this is your first critical number. Don't worry if it's a fraction, you can still locate that in the number line. Okay, so actually the equivalent of 3 halves is 1.5, right? Tama? And here it's x equals 4, so it's easy to locate. Now let's locate this critical numbers in the number line to divide it into sections. So 1.5, that's is it positive? Yes, positive. Oh, positive 1.5. Let me check. This is negative. Turns positive. Okay, negative turns positive. So both are positive. So 1.5 is somewhere here. Okay, in the middle. So positive 1.5 parenthesis here. I'm going to pass along that. Ayan, assuming it's exactly 1.5, we cross 1.5 and positive 4. So meaning the region is very small here. Also, we have wide region 1. I mean, section 1. Section 2 is narrow, yeah, and this one is wider. Okay, so we will now write the intervals. So anyway, it's greater than, the symbol is, open. Going there, it's just non-shaded, and that one, and here it's, ayan, there, symbol is like that, open. Okay, so in the intervals, since open, it should be parentheses. Okay, and infinite parentheses, parenthesis infinite, that's your first, and then you have 1.5 positive 1.5 open. Here it's open 1.5 and then 4. Ayan, and here we have 4 positive infinity. Ayan. Okay, so now you are going to use test points. I can use here 0 since it's part of this section. Okay, 0. Here I'm going to use 2. You can use 3 also. Here I'll use say I'll use 5 in this section, right? Because you're gonna have 5, 6, 7, 8, 9, 10, so on. Here you can have negative huge numbers, but I just want to use 0. Now I'm going to make use of the factor. Okay, the factors here. Alright, so the factors in testing it. So I have 2x minus 3 times x minus 4 greater than 0. Okay, let me have separator, so it will not end with a space. So I'm substituting 0. This becomes 0 minus 3, right? And a 0 minus 4 greater than 0. So it's a negative 3 times the negative 4 greater than 0. Oh yeah, this is negative times negative, so positive. Is positive 12 greater than 0? Yes. Therefore, it's a true. Okay? You see that? Here we will test 2. So we will test 2. 2x minus 3 and x minus 4. Substituting it, that becomes 4 minus 3, right? 4 minus 3. Here 2 minus 4. So I have to write greater than 0. And so this becomes 1 times negative 2, which is greater than 0. So 1 times negative 2 is negative 2. Is negative 2 greater than 0? Oh, it's a false. Very good, no? It's a false. Very good answer. Alright, so let's have the third one. So 2x minus 3 times the quantity x minus 4 greater than 0. Substituting 5, that would be a 10 minus 5, and then 5 minus 4 greater than 0. So 10 minus 5 is a 5, and 5 minus 4 is 1. So greater than 0. 5 times 1 is 5. Is 5 greater than 0? The answer is yes. So it's true. Right? It's true. So, which sections are true to the inequality? Of course, the first and the third. So, how will you write your answer now? So, you're going to write the answer, open parentheses, negative, alright, negative infinite, or ayan, and then the positive 1.5 union with the interval of 4, open interval, no? The positive infinity. You get your answer. Okay, that's your answer. So see, it Maybe it may look like difficult to do, but actually it's very easy. You just have to be familiar with how we did it. And in fact, this is good because upon doing this, we already incorporated 3 lessons: the solving of quadratic equations, the inequalities, and then the intervals. Okay, the interval notations. And I think that's the last example. Thank you so much, guys. I love you all. Bye bye.